Welcome to the Deep Dive. We're here to cut through the noise in cloud engineering and DevOps, pulling out the really crucial stuff for you. Today we're tackling something that honestly can really impact your infrastructure stability. Configuration drift. You spend all this time setting up your cloud environment perfectly right. But how do you make sure it stays that way? Stays resilient against those little unintended changes that just sort of creep in and, well, cause chaos. It's a huge challenge. I think almost everyone in the cloud space runs into this. Leads to endless manual fixes, compliance headaches, nightmare stuff sometimes. But what if there was a really robust way to automatically spot and even fix these issues? If you're leveling up your cloud skills, especially thinking about those tough interview questions, then this deep dive is definitely for you.
Absolutely right. And our goal today, our mission, is to give you a solid, practical solution, something that works in the real world and frankly sounds really good when you explain it. We're going to explore how we enforce CloudFormation drift detection using AWS Config combined with Lambda for auto-remediation. And this isn't just theory. It's a hands-on, interview-ready approach. It's about maintaining that continuous compliance and really slashing your mean time to resolution, your MTTR, how fast you fix things. Okay, so picture this. You're in an interview. They ask, how do you handle CloudFormation drift? Here's that quick professional answer. You'd say something like, well, our approach enforces CloudFormation drift detection by pairing AWS Config's continuous monitoring with Lambda-based auto-remediation. The main goal, maintain infrastructure compliance automatically without needing someone constantly watching over it. I quote, we use the CloudFormation stack drift detection check managed rule in AWS Config that gives us continuous evaluation against the original templates. This rule finds the drift and flags violations almost in real time. Then EventBridge comes in, it orchestrates things.
Yeah.
It catches those config violations and routes them to specific Lambda functions based on, say, the resource type or how bad the drift is. So no more manual detect stack drift commands. The Lambda remediation engine then does the heavy lifting. It has resource-specific logic. Like if an IAM role policy drifts, it uses specific API calls a tacroaim policy, detacroaim policy to fix it. And importantly, if auto-remediation is too risky for a specific drift, we have fallback mechanisms. Generate reports, escalate to a human, give them recommended actions. Quote, the result is continuous compliance. The infrastructure essentially heals itself from common drift, cutting MTTR down from hours, potentially to just minutes.
Okay, that's a really solid summary. Packs a lot in concisely. But let's unpack that a bit more for everyone listening who really wants to get into the weeds, the why and the how.
Yeah.
So first principles. What exactly is CloudFormation drift? And how does this pretty powerful system you described actually work under the hood?
Good question. Simply put, CloudFormation drift is when your deployed AWS resources, the actual things running in your account, no longer match the definitions you laid out in your CloudFormation template. So imagine you defined an S3 bucket in your template, specified encryption settings, logging, whatever. Then someone maybe accidentally, maybe not, goes into the AWS console and manually changes one of those settings. That's drift. Right there. It's like you have a blueprint for a house, but someone paints a wall green without telling the architect or updating the plans. Your actual house doesn't match the blueprint anymore.
Right, the deployed state versus the intended state.
Exactly. Your infrastructure is no longer in its intended state. Now, to understand how the system tackles it, let's use an analogy. It helps, I find. Think of it like a really, really smart home security system. One that doesn't just blare an alarm, but actually tries to fix the problem it sees automatically. So in this picture, AWS Config is like your 24/7 security camera network. It's got eyes everywhere, watching every room, which for us is every resource inside your CloudFormation stacks. And it's constantly comparing what it sees right now with your home's blueprint that's your CloudFormation template. If a chair's moved, a window's open when it shouldn't be, Config spots it, flags it.
Okay, constant vigilance. I like that.
Then you've got EventBridge.
Yeah.
Think of this as the central dispatcher for your security system. The moment Config sees something wrong, EventBridge gets that alert instantly, and it knows exactly who to call, which specialized repair crew to send out, and those crews, there are Lambda functions.
The robotic repair service.
Precisely. Each Lambda function is like a specialized robot, programmed to fix one specific type of problem. So if someone messes with the furniture, maybe makes an unauthorized change to an IAM policy, for example, the right Lambda robot gets dispatched, swoops in, and puts that policy exactly back where the blueprint says it should be. Uses those API calls we mentioned.
Okay, so targeted fixes.
Exactly. Targeted. And what about the really tricky stuff? The problems the robots aren't programmed for, or maybe things that need a human touch. That's where your fallback alerts come in. This is like your human security team on standby. They get a detailed report from the system saying, hey, we found this complex issue. The robots can't handle it. You need to take a look.
So there's an escalation path built in.
There has to be. You can't automate everything safely. And the big benefit of this whole setup, your infrastructure stays aligned with its design automatically for the most part, without you constantly having to step in and fix things manually.
That analogy really does make it click. It paints such a clear picture. And that set it and forget it aspect, well, maybe not completely forget it, but reducing the manual toil, that's huge. I definitely remember times, before robust systems like this, spending hours, sometimes all night, hunting down one tiny configuration change that broke something critical. Knowing this exists is,
Yeah.
well, it's a relief. Okay, but let's shift gears slightly. Let's get into the architecture. For folks listening who might want to build something similar, what were the key design choices, the trade-offs? Because every system like this has them, right? Nothing's ever free.
Absolutely. There are always trade-offs, and understanding them is key to building something effective. Let's talk about detection frequency, for instance. We chose AWS Config rules, that CloudFormation stack drift detection check rules specifically, over maybe just running a scheduled Lambda function every hour or so to check for drift. Why?
Continuous monitoring versus periodic checks.
Exactly. Config gives you continuous monitoring, or near continuous anyway. It's like that security camera being on all the time. It catches drift much, much faster than a check that only runs occasionally. That faster detection directly leads to a lower MTTR. You find out sooner, you can fix it sooner. That's a big win. Then there's the remediation scope. This is a really important one. We deliberately chose to use resource-specific Lambda functions. We didn't build one giant monolithic Lambda function that knows how to fix every possible type of drift for every resource.
Why not? Wouldn't one function be simpler to manage in some ways?
It might seem simpler initially, but it's actually much riskier. Using resource-specific Lambdas lets us achieve very granular permissions. Each Lambda function only needs the exact IAM permissions to fix its specific resource type. A Lambda fixing S3 bucket policies only needs S3 permissions. A Lambda fixing IAM roles only needs IAM permissions.
Ah, the principle of least privilege applied to remediation.
Precisely. And this drastically reduces the blast radius if something goes wrong. If, say, the S3 remediation Lambda has a bug or encounters an unexpected issue, it doesn't affect the IAM remediation Lambda or the EC2 one.
Makes sense. Containment.
Right. Now, the trade-off here is complexity cost. You do end up with more Lambda functions to manage. You do need to be more careful setting up the IAM permissions for each one. It's definitely more upfront work. But, and this is the crucial part, it prevents that scary nuclear option scenario. I've seen it happen where a tiny drift in one resource, because the remediation wasn't granular, somehow led to a decision to just tear down and recreate the entire stack. That can mean significant downtime and risk.
Ouch. Yeah, definitely want to avoid that.
So the slightly higher initial complexity of multiple Lambdas is, in my view, a very worthwhile investment to avoid that kind of operational disaster. And beyond those main points, there are other architectural things to keep in mind, like config rule evaluations aren't always perfectly instantaneous. There can be a slight lag between a change happening and the rule flipping to non-compliant. You need to build some resilience for that, maybe with retries in your Lambda.
Okay, managing expectations around timing.
Yep. And the IAM permissions, again, can't stress this enough. Your Lambdas must have the right permissions for the specific API calls they need to make to fix things. If it needs EC2.authorized security group ingress, it needs exactly that. We also need to think about drift classification. Some drift might be simple, a tag changed, maybe, easy auto-fix, but some drift might involve multiple interdependent resources changing.
Like changing a security group and an instance setting that depends on it.
Exactly. Trying to auto-remediate that could be dangerous. You might fix them in the wrong order or miss a dependency. So you need logic to classify drift severity. Simple stuff. Automate it. Complex stuff. Escalate to a human.
Right, intelligent automation, not just brute force automation.
Precisely. And finally, think about state synchronization. What happens if a change was intentional, but someone just forgot to update the CloudFormation template? Does your system always revert the resource back? Or should there be a process to update the template instead? Teams need a consistent approach here so everyone agrees on the source of truth.
Wow. Okay, that's a fantastic breakdown of the why behind the architecture. Really highlights the strategic thinking involved. It's not just
Mhm.
about hooking services together. It's about these deliberate choices. So now for the really practical bit. For listeners wanting to, get their hands dirty and actually try implementing this, how would they approach it? Conceptually, at least. And maybe more importantly, what do you do when things don't go smoothly? Because let's be honest, in cloud engineering, something always comes up, right?
Slight chuckle. Right. Murphy's Law definitely applies to cloud infrastructure. Okay. Implementation conceptually. First, you set up that AWS config role. Give it a clear name, like CloudFormation Drift Detector. The key is using the AWS Managed Rule Identifier. CloudFormation Stack Drift Detection, check. That tells config what you want it to do, monitor CloudFormation stacks. Second, you configure an EventBridge rule. This rule acts as the listener. You set it up to specifically listen for events from the aus.config source, and you filter those events. You only care about the ones where your config rule, CloudFormation Drift Detector, reports the status of non-compliant.
Got it. So EventBridge is the trigger, waiting for that specific non-compliant signal.
Exactly. When it sees that signal, it triggers your target, which is your Lambda function, or potentially a step function state machine orchestrating multiple Lambdas for more complex workflows. The Lambda function then gets invoked with the event details. It needs to parse that event to figure out which CloudFormation stack is non-compliant. Then, crucially, it usually needs to initiate a CloudFormation drift detection run itself using the API, detect stack drift, just to get the latest detailed drift information. Because the config event might just say non-compliant, not list every drifted resource.
Okay, so the Lambda verifies and gets the specifics.
Yes, and this is where some wait logic or retry logic comes in handy, because detect stack drift is asynchronous. You need to wait for it to complete before you analyze the results. Once it has the detailed drift status, the Lambda iterates through the resources listed as modified or deleted. And for each drifted resource, it executes its remediation logic. Let's stick with that IMM role example. If the Lambda sees an IMM role has drifted, maybe an expected managed policy ARN is missing from the actual properties but present in the expected properties. The Lambda logic would then call, say, IAMClient.attackRolePolicy using the role name and the missing policy ARN.
Okay, it compares expected versus actual and makes the specific API call to fix the difference.
Exactly. Or if an extra unexpected policy is attached, it calls IAMClient.detackrole_policy. Very targeted actions based on the specific drift details. Now, troubleshooting. This is where the real fun begins, right? There are definitely common patterns you'll see. One observation. Config rule shows non-compliant, you check manually, maybe run detect stack drift yourself, and
Done.
find no drift.
Yeah, that sounds confusing. What's happening there?
Often it's a timing thing. The config rule might have evaluated based on slightly older drift status information, or maybe the drift detection process hadn't fully completed when the rule evaluated. The effects. Build retry logic into your Lambda before it starts remediation. Make it call describe stack resource drifts, or check the overall stack drift status again, maybe with some exponential backoff, to be sure the drift is still present right now.
Okay, confirm the drift before acting. Makes sense. What else?
Lambda remediation fails with access denied. The old classic.
Yes, IAM permissions.
99% of the time, yes. The Lambda's execution role simply doesn't have the necessary IAM permissions to make the specific API call needed to fix the resource, like trying to attach a policy but missing IAM.attackRolePolicy. The fix is straightforward but requires diligence, review the logs, identify the failed API call, and grant the precise required permission to the Lambda's execution role. No more, no less.
Least privilege again.
Got it. Then there's the frustrating one. Your Lambda runs, it successfully fixes the drift. You can see the resource is correct in the console, but the AWS config rule stays non-compliant.
It's like the system fixed it, but didn't update the status port.
Chuckles. Exactly like that. The why is usually that config hasn't automatically reevaluated the rule after your Lambda made the fix. It might eventually, but you want it updated sooner. The solution is to have your Lambda, after it successfully remediates the resource, make an API call to put evaluations. You basically tell config, hey, I fixed this, please reevaluate this resource for this rule now. That usually flips it back to compliant quickly.
Proactive status updates.
Nice. Another potential issue, infinite loops. Your Lambda fixes something, but that fix itself maybe triggers another config evaluation which finds something else, or maybe even the same thing again due to timing, triggering the Lambda again.
Oh, a remediation cycle. How do you break out of that?
A common technique is to add metadata, maybe specific tag, to resources when your Lambda remediates them, like remediated by drift automation. Then, your config rule or your Lambda logic can be slightly smarter, maybe ignoring apparent drift if that specific tag is present and was set recently. It helps distinguish intentional automated changes from genuine unauthorized drift.
Clever. Using tags as signals.
And finally, remember that sometimes auto-remediation just isn't the right answer. Complex drift, multiple interdependent
The
resources.
scary stuff we mentioned.
Yeah. If the drift involves, say, a security group, a launch template, and an auto-scaling group update all at once, trying to automatically revert pieces might break things badly. The fix here is that drift classification we talked about. Your Lambda needs logic to assess the type and scope of the drift. Simple, single resource changes. Go ahead, auto-remediate. Complex, multi-resource, or critical resource drift. Don't touch it. Instead, send a detailed alert to your ops team or create a high-priority ticket. Escalate.
So build in safety checks and human escalation paths.
Absolutely critical. But when you put all this together, the config monitoring, the EventBridge routing, the targeted Lambda remediation, the careful permissions, the robust troubleshooting, and the safety checks, you get a really powerful system. It ensures your CloudFormation stacks stay compliant continuously. Instead of constantly putting out fires caused by configuration drift. So, just to wrap up our deep dive today, let's hit those key takeaways one more time. First, continuous vigilance. AWS Config gives you that 247 automated eye, way beyond manual checks, catches drift fast.
Faster detection is key.
Second, intelligent automation. EventBridge and resource-specific Lambdas work together to fix common issues automatically, precisely, without needing someone to step in every time.
Smart fixes, not just any fixes.
Third, resilient design. Using granular Lambdas and having those fallback mechanisms means you avoid that nuclear option. You keep things contained and you slash resolution times down to minutes, not hours.
Reduces risk and speeds things up.
Fourth, permission, precision. Can't say it enough. Getting those IAM permissions right for your Lambdas is absolutely vital, both for security and for making sure the remediation actually works.
Least privilege, always.
And finally, fifth, focus on innovation. Ultimately, this whole setup isn't just about fixing drift, it's about enabling your team. It frees up valuable engineering time so they can build, create, and push the business forward, all within a compliant and stable environment.
Fantastic. We really covered a lot of ground there. From the high-level concept of drift, down through the architectural choices, the implementation steps, and crucially, how to handle things when they go wrong. That was a proper deep dive into a really critical DevOps and cloud engineering topic. And hopefully, for everyone listening, you didn't just learn the what, but also the why behind the design and the how of making it work. This is exactly the kind of detailed understanding that, well, shines in interviews, but more importantly, makes you a much stronger engineer day to day. So think about how you can apply this structured thinking, the analogy, the trade-offs, the troubleshooting to other challenges you're facing.
That's all for this topic. Stay tuned for the next DevOps Cloud interview question.